Greetings, friends. Randall Nagy here. As software developers, we have a unique opportunity to participate in what people are calling the gig economy. Drawing the idea of a gig from the music world, we would have a short stint, perhaps a one-night engagement for your band to play at. The idea of having a gig economy is basing your entire way of making a living off of the ability to do short projects, which will allow us to get a reputation online, a lot like you'd expect to see if you, of course, were in a band playing a musical instrument. The interesting thing about developing your reputation online, however, is that it really does mean that we have to manage the expectations of people who we are creating for. In order to manage that expectation, of course, we have to do several things, the first of which is to make sure we understand before being understood. In other words, we need to understand what our clients want us to do and then tell them how we're going to meet their requirements and, more importantly, translate those requirements into simple steps that allow us to create the software for them. Now, as you may know, I do talk a lot about software design so as to allow ourselves to consider as well as to collaborate over our software development tasks. And I like it so much that I even have a book on Amazon, Design for Beginners. In that book, of course, we talk about several ways to manage and capture requirements, and one of my favorite, although it's not the only way, is to use the Unified Modeling Language, or UML, set of diagrams, as well as other techniques that we'll be talking about later on. So what does a gig look like? Well, of course, the first thing we have is someone we're going to play our keyboard for. In this case, the patron could be somebody from one of the many gig sites popping up across the internet, or they could simply be a neighbor or a friend next door. As a matter of fact, no matter where the client comes from, the patron we're going to be working for is going to have something they want us to do, and that something is usually put succinctly in a mission statement. While the mission statement may be communicated to us verbally, or whether it comes down to a description on a gig site, at some point in time, we need to translate that mission statement into something written that we can go back and forth with our patron so as to make sure not only we understand what's going on, but more importantly, to help manage their expectations so as to make sure they told us everything they expect us to do. So the first thing I do when I hear a mission statement, of course, is to write it down, share it with people, and if they've already written down that mission statement for me, I will create a checklist and break out all the line items, or a shopping list, if you would, of the things they would like me to do, grouping them together in outline format so as to extract the names or the nouns that are in that mission statement, and of course, the verbs or the scenarios that we want each one of those nouns to do. Now, one of the most important people you will ever write software for is going to be yourself. Now that we understand the mission statement to boldly go on Mars, wherever our programs must go, what I'd like you to do, as your time and interest permit, is to take a moment and out loud verbalize a few mission statements that you would like to do for yourself when creating your own software. After speaking out loud, of course, to yourself, and assuming no one is listening, go ahead and then transcribe what you say into a text summary of a paragraph or three that will allow you to discuss the things you want to do, keeping in mind that we have a who, or our actors, what we're trying to do, or scenarios, where, how, why, and when, which all can be factors that we might wish to include in our mission statements. So in order to get a handle on what it takes to create a mission statement, let alone transcribe one from the oral into the written, take a moment, once again as your time and interest permit, and create a mission statement for one or more of your own personal projects that you would like to do to build your resume, to build your community, or simply to have a little fun in your spare time. And then we'll be back to show you how we can go to the next level and decompose a mission statement into a list of requirements that we need to do. So here's an example mission statement. In this particular case, we're going to bid on a gig on a gig site where the user has already taken the time to write her requirements down for us. And we're going to see that what they want us to do is to create an application for them that will allow them to find information on their hard drive so as to find things that are a certain size or a certain date or have a certain file type and list only a certain number of them so they can better manage their hard drive. So before we get into the technical diagrams, the first thing to do would be to take this gig description and put it into our checklist to not only assure our patron that we know what they're asking us to do, but more importantly, to make sure that they haven't forgot to ask us to do something else. As you create your checklists, be sure to keep track of any questions you may have that arise as we decompose the requirements into our checklist. It's all about making sure that we understand what the client wants us to do, so be sure to ask your questions as well as record your client's answers by adding them to our checklist of requirements rather than trying to change the mission statement itself. Now, when taking a mission statement at face value, it's very easy to go through a sentence-by-sentence review and pick out our nouns. For example, here we see program, we see list, we see files, and we see computer. Associating those together, of course, we can understand how we're going to have our program construct a short list, and that list is going to have things that are qualified by either newest files, oldest files, or files of a certain type. Now, easy enough to understand, the opportunity here is to change those nouns from the English world not only into our computer terms, but also to ask the user what they mean by certain things that may be ambiguous. For example, we have the idea of having a certain type, and on the Microsoft Windows world, and increasingly on Linux and elsewhere, a type is usually a dot type like .py or .txt or .csv, but it could also mean other things in other problem domains. For example, in the insurance world, someone might be thinking about a claim form and pictures that are all part of a claim called type, or there might even be a set of information that is collected together into a directory. So easy enough to get started, of course. The idea of listing our nouns and verbs, let alone our qualifiers, such as short list, makes a very easy shopping list to be getting on with. And the first thing we need to do, of course, is to take our shopping list, along with any questions we have, back to our user and ask for clarification. Of course, the reason why we never want to change a mission statement is because people can't attach to their mission statements, and we never really know what they had to do in order to get the mission statement put together. It's what we call in the industry a pride of ownership, so rather than changing anything that a user has given to us, instead we restate that in terms that we can talk about and agree upon and leave the original statements unscathed. While entirely optional, I do find it handy to number my statement reviews so that, once again, as verbiage changes, we can have something constant, for example, M1100, 203. And these numbers sometimes find their way into a diagram and sometimes into our code as well. Keeping in mind, however, that whenever the subject changes, we would be able to go, for example, to M1301 when we discover perhaps the type might have something to do more with file collections rather than individual file types, as we all know and love. So going before our client, the questions I have related to the first statement, that we needed to have a short list from a program, that we wanted to understand what they thought a short list would be, and that would include both a minimum number, perhaps 0 or 1, and a larger number, perhaps 65536 or larger. The next question I'd like to understand, as we mentioned, is where the file is located. They said they were on their computer, but their computer could be a network machine with network drives as well as other computers that could span the cloud and larger infrastructures. Finally, what about new files? Are we interested only in about change files, or could they clarify What do they mean when they talk about files? Are we talking about anything that exists on the hard drive at this very moment only, or things that might have come and gone over time? Another area for clarification. And then likewise, we have to clarify what they mean by newest and oldest. And here we're going to talk about the question to see if the files are actually individual files, perhaps collections put together by a program, as mentioned in the insurance industry. And more importantly, what are we going to be looking for default? Will they be the newest? Default would have to be specified as the oldest. Or more importantly, what are we trying to talk about when we say file types? Do we have the dot types as we mentioned? Are we going to have just name endings? Are we going to be using wildcards or asterisk.txt or CSV? And are we going to be concerned about including or excluding file and directory names? So our forward decomposition assumes, of course, and we must review our assumptions with them, that we are going to have a short list of files displayed using Python 3, that they're only going to be on our personal computer, and we're going to have newest detected by default and oldest as an option, and the file type is not going to be a dot type. And of course, we would look for each and every one of our assumptions to be validated and confirmed by our patron or user. Now, when we're working alone, you might ask yourself if you need to go through this amount of numbering, rigor, and decomposition. The answer is clearly no. But the bigger the project, the more important it is to keep track of all of this information. And as we've discussed, numbers are a very, very important way to keep track of the traceability of our requirements back to an mission statement or other type of document. And it's not uncommon to see these types of requirements listed in a spreadsheet or requirements management system. And certainly, as we have larger projects, we're going to find that requirements are being tracked and numbered, much as we see here. Another reason why I like to track and number my requirements is the closer I get to the person who is holding the purse strings, the more they will indeed nickel and dime you to death. And it's not uncommon to find people who are not interested in having the project executed fairly and equitably for all concerned, but maybe trying to take advantage of us based upon hiding requirements in deliberately ambiguous statements. For example, saying, well, my computer happens to have several clouds and all of NASA's hard drives to search. So by eliminating these ambiguities sooner rather than later, we can first off detect if we even want to work with this person at all. In other words, if they're trying to be less than honest or take advantage of us, or if they really do have a problem that they want us to work on and are willing to work with us constructively so as to make sure that we all understand the problem so that we can keep our time and effort estimates reasonable as well as doable in the first place. So by a general rule, you should know that the bigger the company and the farther away people are from the payment signature process, the easier it is to get clarification and accomplish things in parity or some type of fairness. And of course, the opposite can also be true, especially as we go through different cultures who may not really respect us or our time, or simply trying to get the most out of us by unscrupulous or devious means. Fact of life, hate to bring it up, but something we need to be aware of. And once again, this type of honesty and indemnification is why we must struggle up front to make sure that we eliminate any ambiguities so that we have a shopping list, our checklist, our line upon line of easy to understand things to do that the user has approved and signed off on before we begin working at all on their behalf. As the ultimate subject matter expert on what you would like to do with your own mission statements, now would be a good time to take one of those previously verbalized and transcribed mission statements of your very own and decompose it to see, sentence by sentence and noun by verb, what your official requirements would look like. Take a moment and do that now, and we'll be back to show you how we will use UML to diagram those next steps when you're done. After clarification, of course, the first thing I'm going to want to do is to break down my shopping list into terms that make more sense to both myself and to my client. And I'm going to want to find out, for example, if they want us to create a graphical user interface or more of a DevOps or console way of looking at things. And in this particular case, we're going to discover that they have something called a console user. Because I hope to have business from this client in the future, I'm going to number this as my next client, or customer 427, and their console user is going to feature prominently on my diagram. And the first thing they're going to want to do, of course, is to list the files. Now, what you usually don't find in the use case diagram is a number. As a matter of fact, putting a number on here often will violate some of the rules of UML that says that these diagrams are supposed to be semantically independent of each other. But as much as we might be changing the scenario, in this case, list files might be display files or whatnot, it's important to have a part of the scenario that is immutable or not going to change, and that's why we use the numbers. So no matter whether I call this list files, display files, or grok files, UC1100 provides the name that will allow me to have consistency throughout all of my diagrams. And I recommend numbering, if not in the beginning, certainly shortly after the user approves what we're going to be doing on their behalf. So with UC1100, the next thing they want us to do is, while we're listing files, is to show an ongoing process. Giving an appropriate number, of course, the next thing we do would be to list the files in such a way as to show the oldest first rather than the newest. And of course, related to that would be the opportunity, extension point, or option, if you would, to change the size of a list being displayed to us on the console user's screen. Moving down the list of things to do, of course, the next things we want to do is match the file suffix. Another option or extension point that we can do whenever we're listing files, followed by the ultimate requirement to show our report on another person, place, or thing. In this case, the thing known as a standard display. Now, we know as software developers, we can have standard inputs and standard outputs and standard errors. So whenever we have the standard display, we're talking about things that we can print to whenever our operation is complete successfully. But of course, we have the ability to show errors as well. Probably not something our client originally expected us to be able to do, but something that we need to be aware of, because we know that console user interfaces have to have a way to manage errors just as readily as we can manage successes. So we're going to have an error display, which of course is a standard display. It's just different. But in as much as we're never going to show errors on our standard screen, we need to understand that errors will only be able to be captured on the standard error device. Now that we have a reasonable set of nouns that make sense to us as software developers, as well as may make sense to our users, not to mention the verbs each one of those nouns have to do and the way they will have to interact, take a moment to see if you can begin to start implementing either a solution to our mission statement or, alternatively, to something that you may have been working on defining for yourself. Keep in mind here, it's not important that we have an exhaustive list of everything implemented if you're working on something more complex, but it is important that we begin to understand how we can model our code so as to loosely approximate, if not exactly match, the nouns, for example, a class called console user, or perhaps even a name inspired by our file location process, so as to at least try to have our code match the objects that we're going to be creating to satisfy our checklist of requirements. Now, by the time we start talking standard input, standard output, and standard error, we've either completely impressed our client or we've completely confused them. And based upon our client's ability to understand such geeky details, we may decide to either use more or a lot less geek speak and talk more about the way they describe things in their problem domain. In a like manner, whenever I start working on a main activity, we might, for example, have the need to get into greater detail, but if we're simply going to be executing or updating the programs ourselves, we may not have to do much more than put together a use case and then go merrily off to writing our code. Whenever I'm working with other software developers, however, it can be very handy to allow ourselves to put together an activity to describe the line upon line things I would like others to do for me. And in this case, we're going to go ahead and take a look at the activity diagram for scenario 1100. We're actually starting to list our files so as to talk about our need to get the user options, followed by the need to take a look at a default folder or present working directory. Now, our clients may be DevOps people and be very savvy with the concepts of PWD, or they may simply be describing things for use by other people. And once again, activity diagrams are great, and they can map pretty closely to our code, but sometimes they just confuse our clients completely. Once we go ahead and find our default folder, of course, we know that we have the opportunity to change it from the present working directory or whatever directory we find ourselves in when the user starts our console application, so as to allow them to specify our directory or not. Another opportunity to manage our users' expectations. We're going to assume that we're always going to start in the present working directory, and the user has approved that. Otherwise, we'd have to add an option that will allow them to specify another directory. Once we arrive in our directory, of course, the next thing we need to do is for each folder and file in that directory, list each and every one of those files or folders so that we can get the data that describes the file from the operating system, also known as the metadata, and then see if it's the type of information the user would like us to manage for them. Coming down to the idea of either matching or not matching the information, we're either going to add it to our list of things to show, or of course, ignore it completely, which will allow us to get to our next file. If there are more files, of course, we can understand we're going to have to go ahead and continue the process of metadata matching. Otherwise, if there are no more files, of course, we're done. We can show our final report before exiting our program. In this case, I'm assuming I'm talking to my user, and they're going to want to have a good deal to say about how we manage what's being split on the screen. And after talking with our user, we discovered that they want us to show an exclamation point so that we can know that things have gone wrong. Otherwise, a progress report will allow ourselves to have a period when things are ignored. Otherwise, we are going to have a plus sign when things are added to our list. You'll also notice that we have reference to another activity, AD 1300, which will give us more detail on how we're going to add things to our list, and the ability to reference things like AD 1200. You notice that AD 1100 also includes AD 1200 and 1300, which are diagrams which will talk about predefined procedures, which are diagrams that we will be creating so as to allow ourselves to talk about what types of metadata matching the user would like to see, as well as the way we are going to manage our list whenever data matches those selection criteria. If you're like most of us, you probably could use some more time either implementing your mission statement or implementing the one we've been working with. So, given the information that we've just covered, the greater detail, see if you can either go back and finish your solution or refactor your solution so as to provide a much cleaner interface between the operations of the verbs that we're going to be using on the user's behalf. If the truth be told, it is those interfaces that not only allow us to organize our code better, but also allow us to test our code better, as we'll be demonstrating later on. So if you need some more time, now is the time to take the time and see if you can solidify or refactor your code to provide a clean, functional, or class testing interface that can be used to manage our code and ensure it works properly over time in our upcoming sessions. Now, because the idea of matching is really what our project is all about, we need to make very sure that the objectives are making it onto our AD1200 or file metadata matching activity. So the first thing we need to do is understand whether we're getting our first file or our next file. We're going to have to attempt to get that metadata. And if we can access the metadata, the first thing we're going to want to do is to give the user an option to check to see if the file whose date we're checking is a desired suffix. Hardly required if the suffix option has been specified and it does not match. Of course, we're going to be able to enter a no match state before returning, but more importantly, if it does match, we always want to make sure to see if the file is date qualified. And why? Because we're only managing a list of files, and to simply arbitrarily put a bunch of file suffixes in a list is not going to be very handy for anyone. And if the date is not something we want, of course, we once again enter the no match state. And more importantly, if things do work out well, we're going to enter a match state and tell our calling program that we want to collect the file name that was passed into us as the next file. Interestingly, we'll discover from time to time that we might not have access to a file, and not being able to access a file is so important that the user has required us to report all errors with a separate display on the screen. So in addition to the match and no match condition for our file, we have the third state, or an error state, which will allow us to manage any output or access problems we may encounter when creating this software for our patron. Now, looking back at our top-level use case, you'll notice that errors or exclamation points are being handled separately from our list management logic. And when it comes time to manage our list, of course, in AD1300, we're going to begin simply by taking our qualified file as a parameter and adding it to our list. And if the list is full, what we need to do, of course, is to display a period and add it into the list. Otherwise, we're going to display a plus sign so as to say that we have found our initial item to add to the list. So because there can be many files being displayed, we will only see a plus or a period whenever we add something to our list. And since we know we're going to be adding something to our list and we're only going to have a certain number of items in that list, the main activity of AD1300, of course, is to simply assure that things have been added properly, and more importantly, that we only have a certain number of items being added to our list. Having taken a moment to put together a simple flowchart or activity diagram that details what's going on inside of our interface, it's time to ask ourselves a question. Did taking the time to detail out each step make things easier or more difficult for us to create our code? Well, the idea of having a testable interface is something we need to do no matter how we choose to write our code, either from the top down, or from the diagram to the code, or from the bottom up, from the code to the diagram. The need to provide a clean and testable way to operate our function should be, of course, of obvious benefit. Now that we've taken a look at the interface as well as the operations of our own matching procedure, once again, take a moment to update your code, the third time always being the charm, and see if you could do things a little better and separate the interface a little more cleanly before we return and show you how we had created our code so as to create as well as test our requirements. Now, once our client or patron has approved our design, we're free to start writing code. And the reason why we need to make sure people sign off on what we're going to create for them before we start creating is going to be very important, as we'll demonstrate very soon. Right now, however, doing exactly what our client wanted us to do, the first thing we need to do, of course, is to start off our main to our official command line interface, which will loosely and not exactly follow our design documentation. As a matter of fact, some people do insist that we name things properly in our diagrams, but to tell you the truth, that's very unrealistic. And I discovered that over time, diagrams are great for getting us started, and unless they're paying us to make sure that the diagrams completely match things, all we're doing with diagramming techniques is to manage your expectations and creating that mythical laundry list that we're going to need to make sure we've done everything they asked us to do. If you're not already familiar with it, I suggest you learn how to use argparse. It's a standard module in Python, which allows us to create an argument parser and then manage the command line arguments that we're going to be needing to put into it. At this point in time, we should note that what we have going on here is simply the ability to do our requisite list, which will allow ourselves to give a little help string for the user to become familiar with, where we're going to tell them it's the number to list. Then, to allow ourselves to store an action, we're going to be using the oldest first, followed by the ability to specify, of course, our suffix before checking to see if something is the newest or the oldest. Once again, pretty much following our requirements in our user's mission statement. Once we go ahead with these three basic arguments, the way we activate the parser, of course, is to allow it to inspect the system parameters passed into us by calling the .parseArgs, and then we can actually check to see if things are working the way they should be. In this case, we told it to check to see if the list capability was specified, and if the list has not been specified, in other words, we're taking the default, we're going to replace that default with a number of 25, which will allow the argument parser to store an integer on our behalf, or to tell the user what they need to use the -l parameter to do. The next thing, of course, is to do the same thing for our suffix. In other words, if the suffix has not been provided, in other words, we're not going to allow ourselves to have anything to check at the end of our file, and we're not using wildcards, by the way, that wasn't a requirement. All we have to do, of course, is to make our suffix none, or in this case, an empty string, and then we are going to talk about creating a class called FileList that will allow ourselves to have those parameters defined. You remember from our diagram, we had the requirement to use a present working directory, or PWD, as a default, and since we know the client might feasibly want that to change, but once again, making sure we manage expectations properly, the first argument to file list will be a period, as we may know is our present working directory, followed by the suffix, and that will create our class at least good enough so that we can allow ourselves to work on a member function that we are arbitrarily calling locate. Using the enumeration syntax, we're going to provide some parameters to locate that will allow us to take the maximum list size to be managed on our behalf. Once again, noting that that list size did indeed come from our -l option, which was defaulted to 25 in the event it wasn't there. And in a like manner, we're going to check to see if we're going to be checking the oldest by simply negating the user true or false, so as to allow the locate to have two parameters, a max as well as a newest, and of course this will allow ourselves to enumerate things based upon the number 1, which is a good indication that we're doing things for a human. Once we begin to enumerate from 1 to the size of the information being passed back to us from Walker, we're going to use an F string here, which means we're going to be using Python 3.6 or greater, so as to format up the ones base number, followed by 2 parameters that will be represented by info, one being the file name, and the, of course, being a file date, so as to show us what's going on inside of that directory. So the next thing we're going to want to do is to import the modules that we need to get the task done. In this case, we're talking about os.path, sys, as well as the datetime module. Knowing that we have to have a class, we're going to start off with our customary documentation so as to allow ourselves to keep track of what we're doing, followed by our initialization with our requisite self, our present working directory, which is going to default to a period, which again, coming to our requirements, as well as allow us to default to nothing, to remind us that we could have a suffix being omitted. We're not going to use none, but we're rather going to use an empty string. More documentation, of course, will allow ourselves to transcribe what we have en route into our own self, as well as create a list for our results. Once again, keeping in mind, we are managing how many items are coming back. Finally, to allow ourselves to take whatever is given to us to a lowercase suffix so as to make matching a lot easier as well. Our locate function is very easy to understand, once again using the default parameter of 25 and assuming that we are looking for newest rather than oldest, once again coming from our mission statement from our user. The next thing we want to do is use the venerable os.walk command so as to return the ubiquitous root, the directories found in our present directory, as well as the nodes found in our present directory, as we enumerate down through our starting directory. If you haven't used os.walk, this is a great tool. I use it a lot when I'm doing DevOps work. And more importantly, as we begin to start managing all the information that is iterated back from os.walk, we could take a look at each one of our node, which would be a file, to check for that metadata. Knowing that we are not going to be showing the result to the user, of course, we can take the name that we're going to be matching on down to lowercase, simply going to be a string, and check to see if the string ends with none or it's going to end with the desired suffix. If it doesn't match our desired suffix, which requires a little in the know on our behalf, we're going to continue on to our next node, and more importantly, we're going to reconstitute the entire file path or fully qualified path by taking the root folder that we started with or the user gave us, noting our default is a dot, take our path separator, then adding our node to that file name so as to see by using the os.stat command if we're able to get the metadata from that fully qualified file. Follow symlinks is very handy on Linux, and it's increasingly being important on other operating systems. But in this case, we're going to say following symbolic links is something we don't want to do, a very handy convention because not all Python platforms do have symbolic links. And if we cannot access this file, keep in mind the file could really be there, but we just don't have the permissions to read, write, or execute it, or even look at it based on either POSIX file sift or, of course, on Microsoft Windows and elsewhere. Then we're going to print our requisite exclamation point on the screen, and we're not going to advance the line because we want to see these little dots and dashes all print across the screen, something that was once again documented on our diagrams. So assuming we don't have an exception, of course, and we're not going to print our exclamation point to show that things went horribly wrong, we're going to allow ourselves to get that metadata, the STM time, which returned from our stat command, and if our results, which we haven't put anything into our results yet, are greater than the maximum amount that has been passed on, defaulting to 25, of course, we're going to do one of two things. If they're not at the maximum yet, we're going to prime our list. We haven't created a prime function yet. We will shortly, but matching our requirement, we're going to put the plus sign on our progressively listing display. And if we are replacing, in other words, we are greater than or equal to max, we're going to use a function called prospect so as to check to see if the file as well as the M time in the newest exact same three parameters, nothing different there, are something that'll qualify for our replacement process, in which case we're going to want to display our requisite period. So we have our exclamation point, our plus, and our period, once again, just as the user required of us. And while we may change the name of our functions, obviously what they see on the screen, on the display, is a lot less flexible. And given with our need to only have a certain number of items in our list, of course, usually adding one, we're going to go ahead and play it safe and simply pop things over and over again, simply because whenever we have the ability to have another function managed elsewhere, it's better to be safe than sorry. Now, an interesting technique that I've talked about in my other Python training that I want to make sure that we go through here is the ability to flush something to the screen. Whenever we're using Python and different operating systems, a lot of things are buffered in memory until we get a new line. And because we want our shorthand notation, whether we have an error or a priming event or a replacement event to show on the screen, since we're not using a new line, we're going to have to flush the standard output. An intermediately and somewhat advanced technique I want you to be aware of whenever we want to make sure that we have an immediate update to anything we're writing on the screen or perhaps to our hard drive, which we talked about in Python 3000 file IO. Once we're done, in other words, once all of this has been completed, the next thing we want to do is simply make sure that we print that missing new line to terminate our progress display, and then clean up by showing everything we put into our results, making sure there's a clean separation between the little Morse code going on our screen, if you would, and our final report. Once again, the names of these functions aren't really all that important. The output really is, because our user asked for this type of output. So, to continue on our example, let's take a look at prospecting, a very easy idea. I like to start off my function definitions with returning false rather than none. And we're going to go through each and every one of our results to see if the modification time, which is going to be put in the second member in our collection, is absolutely something that we should have or is something we should bump, and whether we're going to be using it or not depends upon whether we're looking for the oldest or the newest. So we're going to invert should if we're looking for the newest. Otherwise, obviously, what we want to do is insert something at the location that we're inspecting, and therefore cut in front of the line and push whatever we have down to the bottom, so that, of course, we can pop it, as we've talked about previously, in our locate function. Once we insert something, of course, no matter where we are in an iteration, we only have one thing to worry about, so we're going to return true immediately. Otherwise, once we get through everything, and it shouldn't be included in the list, of course, we're going to return false, which will allow ourselves to now talk about a function that returns the plus sign so as to allow itself to be primed as part of our list. As you might expect, the rule of reuse is very much in effect here. We're using the exact same parameters. And if we find that we should use something and it returns true, then of course we're going to allow ourselves to append it. Otherwise, of course, we are going to allow ourselves to return none, because the value here being returned is going to be ignored. All we're trying to do is prime things, and we do check to see if we have enough by checking the lengths of our max whenever we have located something in our main loop. A lot of people don't like to break up segregation like that. In other words, we don't like to control the addition of something using another member function, but because we've marked these things as private, of course, allows us to take some license with the idea that we trust people won't be changing our assumptions, and they will allow us to use our private members for ourselves. Cleaning up is really easy to do, because we're going to allow ourselves to clean up things so as to have a result list populated from our results plural. And as we go ahead and take a look at each one of our data that is put into our list, we are going to get the second parameter, that magical M time, if you would, a modification time that we've taken a look at. And we're going to assume it's a timestamp using the date and time module to actually format up something we're calling Z time, not PEP8, but certainly one of my personal conventions. And more importantly, to allow ourselves to use the string format feature of the date time so as to allow ourselves to put the year, the month, the day, as well as the hour and minute into a format so as to put our results into a list that we can use later on. Keeping in mind that once we're done here, we're going to clear our internal results, in other words, prepare ourselves for use elsewhere, which really isn't required, but certainly a way to let us know the internal state before we return our final results. Now that we've seen how we're going to get all the information we need from our cleanup operation, of course, we know that we're going to get a list of lists, which brings us right back to our enumeration capability, where we take a look at info 1 that we just saw being put into our result list, followed by info 0 to make things run as expected. Right now, we're not seeing very much because we're in my study where I have something called file list 01. And we're going to go ahead and take the result of our first program to our user. And if they like what they've seen, they may simply be happy and pass, or they might ask us for more features. Whenever I get done writing code, I'm often very anxious to share it with other people. And that is probably one of the biggest mistakes you could ever make, whether you're working with a team or you're working with a client. What we need to do, first and foremost, is to make sure we have done everything that we set out to do. Often referred to as a completeness check, the difference between being good and being great is taking the extra time to do the non-coding activities so as to compare our requirements, our mission statements, and any artifacts or designs that we have done against the code we have created. So while we are free to do our own coding and unit testing to make sure everything is working properly, when you think it's done, rather than having someone tell us that we didn't do everything we were asked to do, make sure to do a post-action survey comparing our input artifacts with what we are delivering before delivering it to the testers, before delivering it to the client, and certainly before considering that we have given our best effort and everything is accomplished. So take a moment now and review our solution against the requirements, most importantly those key number requirements, and donning the tester or the user's hat, make sure that the mission statement can actually be completed using the software that we have just created. You know, when we first created this training, AI wasn't really even a thing a few years ago. So let's go ahead and update our training so as to use artificial intelligence so as to take our problem statement as we've been working through, paste it into an artificial intelligence agent. In this case, we're using GitHub's wonderful Copilot, and see what kind of code artificial intelligence is able to generate for us. And you notice we're using GPT 4.1. We have some good insights into how to use the program, as well as a not required option and count, which seems to indicate to me that someone's been taking a look at my solution so as to put this wonderful code together, which looks a lot like the code we just talked about, with, of course, some interesting updates and definitions. Saving this code out, I'll go ahead and update the archive to show this code, simply so as to demonstrate how specific we need to get when sharing our requirements with an AI code generator. Switching over to our favorite word processor, of course, the first thing we need to note is we're going to have our basic mission statement. We're going to need to have an argparse program created in Python to display a date-sorted list of files. Breaking down the outline, of course, we should note that, unlike we have seen, while a nice enough feature, it wasn't the requirement to start off in our present working directory. So we should tell the AI what to do. And next, talk about our two types of displays. We wanted to have the program to have a progress display where we see our little punctuation followed by no new lines, as well as the final reporting display. So the two displays, of course, we should probably first start with the idea of detecting the list of files to sort the list, whether that's for the oldest or the newest, based upon the descending order of the date and time, and to make sure that we have the human's ones-based way of looking at that report beginning with number 1. Now, the file detection display, although very simple, is kind of difficult to talk about because we have the requirement to either print a single plus or a period or an exclamation point on our screen, and as previously discussed, to say either things were added or updated in our finite list, or when things were skipped, and of course an exclamation points when things go horribly, horribly bad. Ultimately, we need to mention that the progress display has no new lines to be printed while the detection process is ongoing, but we should have a new line printed both before and after all file detections. Incredibly specific. So let's talk about those command line options, as we've seen. And as also assumed by our first generative session, we want to make sure to have our optional command line so as to support an optional list option. Put it in quotes will increase the probability of actually being literal on the command line. If specified, of course, we're going to limit our list to a certain numbers, and the default number of files, as we've previously seen, is going to be 25 files in our final report. The second option, of course, is an optional capability to match a suffix on each one of our file names, and of course we'd go ahead and specify that the default file suffix is simply going to be an empty string, simply to see how close it gets to the code that we ourselves have manually created. Ultimately, our third and final requirement is to support an optional oldest option, once again, as we've seen in our solution, to invert the window to list all of the oldest files, rather than the newest, and whatever numbers to be in our list. Easy enough to be getting along with. Let's go ahead and copy and paste our new requirement over to GitHub to see how close it gets to the solution to our own hard-coded and manually created solution. Saved here in the list files by date.py again. We notice that we still had some assumptions that we didn't specify at the time of this recording. Going a little bit beyond what we told it to do is a good news as well as a bad news situation. Taking a look first at our argparse, you'll notice that we have the list, we have the suffix, and we have the oldest. Looks pretty good, but they also went ahead and presumptuously put a path in there as well, and they did a little odd thing that would have to fix up. And this is very much what we see when we're using artificial intelligence, is sometimes AI thinks they're a lot smarter than we are, and we've got to manage the problems and fix things as we might expect. Nice idea here to simply have the standard out flush capability. While it's not basically required, it is an excellent idea. So once again, AI doing a little bit better than we did in our own code. But more importantly, we have the idea of not being is file, rather not just the metadata, allowing us to print our options before using os.path.join to do the same thing we had to do. Works pretty much the same as we saw. So eventually, of course, the exception would be to get the modification time, and having the flush also printed out to the screen is really the major takeaway point here. Before appending only the successful file activity to our file list, printing plus, otherwise here again printing our exclamation point on line 47 as well as line 53 whenever things go horribly, horribly wrong. And I really like the way, of course, that we had the intent of using end equals nothing before putting our new lines above and beyond the report. Very easy to enhance, and I also love the idea of using the lambda feature to sort our oldest files based upon our ARG specification. A little dicey there. And of course, once again, showing our report display, which wasn't really required, but certainly is easy to manage if we don't like to have that capability. So downloading that file, and once again, I'll share that with you. The conclusion we can have about AI is it can be incredibly faster to generate our code than the half hour or so it would have taken for us to do it in the first place, but we're probably going to spend some time fixing things up after the code has been created. But certainly a huge time saving here, and AI is certainly something we need to have in our gig toolkit, keeping in mind that the idea of setting up test cases for the unit, for the system, for the integration, for the acceptance are all part of the real work that really no one likes to do until you start doing a lot of it. Whenever updating our gig success process to use artificial intelligence in 2005, or at the time of this recording. Now, much like when we are creating documentation and managing the expectations of our patrons or users, the idea of testing is also something that might be more or less required based upon the type of software we have been creating. At this point in time, before we go to our user, we're going to go ahead and demonstrate how we could test an application such as file list. And one of the reasons why people do not like testing, something as simple as locating files can be very difficult to test, given that we'd have to set up a known set of operations to check for so as to make sure we're getting the same test results over and over again. Because there are many ways to create a testing framework, we have provided a black box in the form of a zip file that when we open it up will have several nodes that we have created using Python so as to allow ourselves to create our testing framework. Now, the way you choose to name your classes in your testing framework may be different, but we decided to simply have a T in front of our file names whenever we are having a test case. And of course, there are many conventions that we can use when creating something like we have here, known as our test main. Yet another reason why it's very nice to create our testing frameworks beforehand is we're often going to run into needs, for example, in this case, to set up our home directory that would probably very much match the needs of our clients in the future. The first thing we need to do, therefore, is to create our testing program, providing the name of the folder we want to test from, and of course, after changing directory to that program using Python, all we have to do is run our test program. Once things begin to get tested, of course, there are two ways to track success or failure. One is to say a lot, and another is to say nothing unless something goes wrong, and opting to choose the former, you can see whenever we run our test application, after having extracted our test files from our zip, we see that there are no problems to be concerned with. And conversely, switching over so as to change the information in that exact same structure, when we run our program, of course, we will see that there has been something different, thus allowing us to complete a rather minimalist way of testing the features that we have just provided for our user. Of course, the need to test each and every one of our command line interface options is important. And just as important would be to test a combination of each and every one of those options so as to give us an idea of what the user might be using whenever they run our command line interface as well. Whenever we're trying to find the complete list of options that we might have to test, we obviously would want to use a truth table, which will allow us to choose individual options as well as combinations so as to exercise a complete set of options that a user might be using whenever they're using our command line interface. By the time we've exhaustively gone through a truth table to test each and every one of our command line interface options, you begin to understand why most companies prefer to hire full-time testers so that they can make sure that a complete set of options have been tested for which is not usually what we want to be doing whenever we run our own test cases or unit test cases when working alone. So we can see the need to have a unit test or the type of testings we will be doing so as to improve our confidence that things are working properly, as opposed to the type of testing somebody who was trying to test every way a system may be used, or if you would not use properly, can be just as important. So we typically have a distinction between the way we test our software or our unit testing and the way someone else might be testing our software whenever it's completed, or, as we're seeing here, a set of tests that we run against the final system or system testing. The idea, of course, is to make sure that we're testing something that our user might be using every day in the way they might be using it, so as to keep them from being upset whenever those features unexpectedly change in between our software releases. For example, looking for the list size, as well as we're looking for the odor, should remain the same, because the user might have written other programs that based their operations upon the output, just like you see us doing here in our test cases. So just like our patrons or users' tolerance for documentation may change, so too may our requirements for doing testing be different based upon the simplicity or increasing complexity of the project we're creating on their behalf. So as a general rule, as our systems begin to become more and more complex, we should be spending more and more time creating test cases that not only ensure that each and every feature and function is being tested, but more importantly, that these uniform set of test cases can be run automatically and at the push of a button each and every time a module is either checked in the ideal world, or certainly before software is being released to our client at an absolute minimum. Now, just like you, whenever I get done writing my code and my unit tests seem to be good enough to me, and more importantly, my completeness checks tells me pretty much that my patron or client is going to be very happy with the work I've done for them, I often stumble at the opportunity to finally don the hat of a tester so as to make sure everything works tomorrow as well as it does today. Unlike every other technology that I'm aware of, however, when it comes to testing, from using doc strings to unit test frameworks to even having operating systems interfaces like we see with POpen to allow ourselves to test our applications as if a user was typing on the keyboard, I find very little excuse for not assuming the black box technique so as to test any application, much like a user would be doing in the real world. So noted, therefore, take a moment now to write your own test cases for either your mission or for our mission, to make sure that as we add value to this solution, that things do not break, and more importantly, when they do break, and they surely will, to make sure that we can detect them instantaneously, certainly as soon as the code is broken, so we know precisely what was done that caused the problem, so as to decrease the amount of time it takes us to fix the problem that we have introduced. What does our process look like so far? Well, of course, we know we have to start off with our client. No matter what we choose to call him or her, they're going to come up with a mission statement for us. And whether that statement is oral or written, the most important thing, of course, is to write the statement down so that we have something to negotiate over, certainly something that we can use to clarify what we need to be doing for the mission, so we can go into our mission acceptance phase. Now, as we mentioned, we should always seek clarification without modifying the mission statement because of that pride of ownership situation, as well as expect to come away with a formal list of requirements defined so that we can enter our formal agreement talking realistically about the step-by-step checklist of the things we need to do so as to complete the project. Of course, the formal project definition should include a project design, certainly enough to allow ourselves to talk about the delivery technologies let alone the idea of planning the handoff or visible portions of our delivery, and we're giving them the amount of attention that they feel is appropriate for our level of compensation. So the way we decide to deliver or test our final product may be all at once, as most gigs are, or it might be in a phased approach, which brings us into the concept of the payment process, which on most gig sites is simply to pay you after everything is accepted, or on larger projects, the delivery planning may include a series of smaller incremental deliveries where we are paid for the value we demonstrate in each delivery step. All part of the formal agreement, of course. It's very important that we have the project design, delivery planning, and any testing, acceptance, and payment process defined up front before we put on the software development hat or work with our project developer so as to execute the plan. Keep in mind, it's all about parity or fairness. And the idea here is that we are all working together with good intent to make sure that we are delivering the best product possible, earning our clients' confidence every step of the way. Of course, from our point of view, being software developers, when we start developing our project, we're going to create code, but we're also going to have the unit testing, and more importantly, when we're done with our unit testing, or certainly while we're developing our code, we need to be reviewing those requirements to make sure we're doing what we're being paid to do, and more importantly, we're delivering according to our formal agreements, either all at once or incrementally within the appropriate time frame. Of course, we can also don the hat of being the software tester, and whenever we have to do testing, we should make sure after the project development phase is done, or the project developer has completed the task that he or she has been assigned, that this system is being tested properly. By reviewing the requirements, of course, the project tester is simply going to operate the system, typically in a black box way, so as to do the same type of things the client or patron will be doing without them actually doing it or seeing it being done on their behalf. Working, of course, with the idea of automation and having regression testing tools can become incredibly important. And while optional, therefore the extend relationship, the more increments or deliveries we have or are anticipating, the more important creating a regression testing or regression test plan can be, and brings us to the idea of automatic versus manual testing. Ultimately, however, after the project tester has determined that everything is very much the way it should be, the project analyst or project manager or user liaison, whatever the title would be called, would next work with the client patron to make sure everything is working properly, once again, in accordance with our formal agreement. And just as importantly, if we have anything going wrong, we would obviously have to have some type of defect reporting or bug tracking or software management system that will allow us to work with the software developer, both as a tester as well as an implementer, to make sure that those defects are corrected. Once again, a process that can be explicitly defined as part of the delivery plan, or is often simply assumed to take place during the implementation as well as user acceptance testing phases. Stepping back and taking a look at the process as a whole, it looks like we have a lot of things going on, and understanding that there are many small steps involved, even in processes that are generally well understood, is yet another reason why it can be so important to make sure that we design our system detailing each and every one of the steps involved so as to allow everyone involved in this process to understand what needs to be done so as to justify the high cost expressed both in terms of time as well as resources that have to be spent in order to have a mission statement delivered and tested properly. When reviewing use case diagrams, certainly a la UML, remember that whenever we have the include relationship, it's something that we really must do, certainly something that should be considered imperative, if not highly desirable, and the extension points are things that we probably would want to do, but may or may not, depending upon the needs of the client, situation, or overall delivery strategy. At this point in time, we should probably mention that if you're interested in learning more about how to ensure testing success, that we do have a training under that name available on this training content provider. In a like manner, if you're interested in learning more about successful requirement gathering and design collaboration processes, we have other titles dedicated to mastering the software and requirement design process available as well.